Hello everyone. I hope I'm audible. If not, please let me know. Okay. Last week we have started with the root locus method, and we compared it with the standard technique like Routh-Hurwitz criterion, and all. We discussed what are all the advantages and how this is advantageous than Routh-Hurwitz, because Routh-Hurwitz can tell you whether the system is stable or not for some range of values of k, right? But root locus method can let you visualize how the system stability would be when changing the values from k to infinite value with only the open loop poles. No need to go through all the steps of finding the closed loop system or closed loop transfer function. With the help of the number of open loop poles and the location of open loop poles and zeros, you will be able to see the entire system movement, stability and performance wise movement for the varying values from k equal to 0 to k equal to infinity. So this is the most advantageous points when compared to the one we studied previously, Routh-Hurwitz, versus the one we are studying now in this week 6, root locus technique. Okay, this is dedicated for a time domain system which has time domain specifications. Later in the upcoming classes, we will be seeing how we can approach the same system from frequency domain viewpoint. Okay, for that we use different tools like Bode plot, Nyquist plot, and all. Okay, let's just wrap up the root locus technique in this class today. Okay, for finding the root locus of a particular system, we have seen some rules. In the presentation, you would have encountered some rule 7. So we have not discussed all of those rules. We just took some preliminary example yesterday and tried to solve around it to get you familiar with it. Now I would like to take another problem. In the same way, we will solve and we'll see each rule one by one. Okay, right. So, till now, in the yesterday class or the one you saw the videos, if you have any doubt, you can ask me. I remember one doubt that angle criterion one student asked that I'm going to explain it now. Other than that, if someone else has any different doubts, you can ask me now. Otherwise, we can go ahead. Okay, I think my pencil doesn't have channel. Give it a minute. We'll see the presentation before that time. Okay, right. From here we can start. So, in the presentation, they have given few examples for explaining each and every points. So, we'll start with rule 1. Right. So, rule 1 suggests the root locus is symmetrical about real axis and the number of branches is equal to the order of characteristic polynomial. So, whenever you have a root locus in your real axis, it will be symmetrical, and the number of branches will be equal to the order of the characteristic polynomial, or number of the poles in the denominator. Whatever the highest order, that many number of poles you have, that many branches you will have in your real axis. That many branches of root locus you will have in the real axis. So the shortcut is number of poles is equal to number of branches. This is rule 1. The second rule suggests always starts with open loop poles and ends at open loop zeros. Whenever you have a system, loop transfer function, you just see how many poles you have and count how many zeros you have in your system. And the root locus will always start with the number of poles and ends with the number of zeros. For example, you have 3 poles and 3 zeros. So all the root locus that starts with open loop poles will end up in open loop zeros. If you have 3 poles and 2 zeros, two of the open loop poles, any two of the open loop poles can start with the any two of the root locus can start with the open loop poles and end at open loop 0. The one remaining root locus will start from open loop pole and end at infinity. So whatever pole that is in excess than your 0 will go to infinity. That is the point here. What if the zeros are in excess compared to poles? So then a root locus will come from infinity and reach to that zeros. That's all. So whenever there are equal number of poles, equal number of zeros, they will start with one pole and end at another zeros. That's it. If one or two is in excess, the remaining will go to infinity if the pole is larger, or it will come from infinity to the zero if the zeros are larger. Okay. I hope this is clear. The first point is number of branches equal to number of poles. Yeah, Dhruv, what doubt you have?
Ma'am, can two poles end up in 1 0?
No, it cannot. Two poles won't end up in the same zeros. Okay, the another pole will go to some infinity if there is no other zeros. Okay, then this is the rule 2. This is simple, doesn't need any formula to remember. That's it. We are moving to rule 3. Rule 3 suggests a point on a real axis lies on the root locus if the sum of poles on the real axis is right to the point of odd number. For example, in root locus, if you want to see whether this point, we will take one test point in the real axis and we'll check for whether it is lying in the root locus or not by seeing how many number of poles and zeros. You cannot consider only poles or only zeros. You should consider poles and zeros together. Students used to make mistakes here. So you should look for combining poles and zeros to the right of your test point. So if that number of poles and zeros are in odd numbers, then you can consider that test point is in the root locus. Otherwise it is not. So why it is odd number? Because we always look for odd number of repetitive values, because when you when you circle towards, for example, if you take a test point and if you see a pole or a zero towards your right, then that is at 0 degrees to your test point. And if you are standing in the same test point and seeing towards your left some poles or zeros, anything, then it is at minus 180 degree to your test point, right? So wherever you want to go in the real axis, you would end up either at 0 or at 180. For example, or at minus 180. For example, if there is a pole or a zero in my left hand side from my test point, I am standing on the test point and there is a pole or zero in the left direction of me in the real axis. I can go at either 180 degree or minus 180 degree. Both ways I will end up at the same location. That's why to make it consistent, we are using plus or minus 180. And again, this whole circle will happen only if it is odd number of circles. For example, you can end up in the same point at 180 degree. Again, if you want to reach the same point, you should circle 360 degree again, right? So, to overcome that point, to come to the point again. Then it adds another 360 degree, it becomes 540 degree. So that's why we have 2q plus 1 plus or minus of 180 degree. So this is your criteria. So always you will consider this. And one inner catch point here is, if you have a pole that is a complex conjugate, for example, 1 plus 2j, 1 minus 2j, 1 minus 1 2 plus 2j minus 1 minus 2j. These are complex stable poles, right, left half of the S-plane. So when you calculate this angle criterion, the top positive conjugate angle will make some degree theta 1, and the negative conjugate angle will make the same degree but in opposite direction. So this will cancel out each other when you calculate that summation of poles directions. So that you should keep it in mind, nothing else, right? I hope 3 rules are clear. Number of branches equal to number of poles. You should look like always from open loop poles to open loop zeros, and you should consider whether the test point is in the root locus whenever there are any sum of poles and zeros to your right of side is odd number.
Ma'am,
Yeah,
ma'am, can you go to that previous slide?
this one.
Yes, ma'am.
Yeah.
Ma'am, this question I was asking last class, like why is it that if I'm going from -3 to -2, it is 180 degree, and like going to -4, it is 0 degree? Like what concept is this? I'm not getting.
Okay. Here the test point is S0. In the diagram, can you see S0?
Yes, ma'am.
Okay. From S0, thinking, imagine that you are standing on S0 and you want to jump to P3 first. When you want to jump to P3, if you keep a protractor over there, Z1 will be at 0 degree. P3 will be at 180 degree, or P3 will be at 0 degree, or Z1 will be at 180 degree. Both ways it is possible. Is it clear?
Yes, ma'am.
Yeah. So the same way you can reach to the same point to 0 degree or minus 180 degree also. So here we are considering P1, I guess. When from S0 to P1, where it is P1, it is in the origin. So I'm seeing towards the right of right angle towards, sorry. Wait, from P3 it is 0, right? Okay, I'm looking from P1 to S0. From P1 to S0, it will be, if it is in my left, it is 180 degree. Just follow one notation. In protector, there will be 2 ways. When you fix right 0, left 180 degree, always follow wherever test point you start with, follow right 0, left 180. Otherwise, you can mix up that, but don't do in between. Right? Follow that for all the test points. That's how they have followed. They have followed from S0, right 180, left 0. So whenever you are seeing P1, P2, Z1, it is 180. Whenever you are seeing P3, Z2, P4, it is 0. The another thing, when seeing from Z3, that is a complex conjugate pairs, it compensates itself, because the degree the Z3 positive makes and the Z3 negative conjugate makes are same but in the opposite direction, so they compensate themselves. They won't get to be added on. It will be 0 degree. Maybe if it is in the 60 degree, Z3 makes 60, Z3 dash makes minus 60, it will be compensated by themselves. Clear?
Ma'am, we are keeping 0 and S0.
Yeah, like imagine it as a protractor. Protractor has 2 ways, right? One inner side will have 0, 180 one direction. Outer side has 180 0 in the same direction. So fix one for your convenient. Whenever you are seeing from a point, whenever you are seeing to the right, here they are followed 180 towards the right, 0 towards the left. So when you are seeing from S0 to P1, in the protector, that is the rightmost point, that is 180 degree. In the leftmost point, it is 0 degree. So when it is lying on the same real axis, from a test point, whatever lies towards your right is 180, towards your left is 0. It is also okay to consider right 0 and left 180, but it should be the same for considering all the test points. That's what I want to, like, let me explain it. See, if you take a protractor, there will be 2 points, right? 0, 180, and outer will be 0, 180. So when I take a test point, I can consider outer or inner, whatever I want to, right? Based on my position and based on my convenience. So here they have considered this is S0, this is Z1, P2, P3, this is P1, right? This is P3, Z2, P4. So what all the points lies on the same line, real axis. So whatever I am considering towards my left, that takes 180 degree to reach there. Whatever I am considering towards my left, that takes 0 degree to reach there. That's why this Z1 is 180, Z4 is 0. Where is the Z4? Okay, P4 here, this one. Is it clear or still you have
Yes, ma'am, it's clear.
clear, right? Okay. Okay, right. Good. The rule 3 is this, like the root locus will be considered only if you have odd number of poles and zeros in your right side whenever you are taking a test point. Okay. And the fourth rule is lecture 4. Fourth rule is, right, till now we have setting up the basics, like how, where is the root locus in the real axis. Hereafter only we are going to construct the root locus, how the root locus actually is going to deviate from the real plane, how it is going to evolve, or how it is going to travel from real poles, open loop poles to open loop zeros. So the first thing we need to calculate it, at what angle it is going to travel from open loop poles to zeros or either to infinity based on the number of poles and zeros. The first value you have to calculate is asymptotes angles. So this asymptotic angles will tell, like this asymptotic angles will be in the number of n minus n based on your number of poles minus number of zeros. If you have 3 poles and 1 zero, this will be 2, there will be 2 asymptotes, right? It will be calculated based on this formula. Just you have to put q equal to 0, 1 based on the number of value you are getting here, some x, and the same nm, 3, 1, whatever number of poles and whatever number of zeros you have. This will tell you from real axis or from the open loop poles how much angle it is going to, at how, what angle it is going to travel to open loop zeros or infinity. The second thing is you have to find the centroid. Centroid represents, this is particularly important when there is a pole that travels to infinity, the root locus that travels from poles to infinity. This will tell from which point it is going to travel. Maybe there are 3 poles. So there must be, for example, 0, 1, 2, 0, 1, 2, all the 3 poles. You don't know from which point it is going to deviate, right? Or from which point it is going to travel. You know at what angle it is going, but from which point it is going, that will be given by this centroid. So there's a formula for centroid is just add the values of poles and values of zeros and divided by number of poles minus number of zeros. Please don't get confused of this. The numerator should be the values of pole minus values of zeros divided by number of poles minus number of zeros. This will give you the centroid. It's like taking an average, that's it. Median, finding a median value for it. Right, this is rule 5. Rule 6 tells breakaway and break-in points. So when there are too many poles or zeros that involves in a root locus, for example, I am considering a root locus like this, zeros and some zeros here, complex conjugate zeros. So there are 3 poles and 3 zeros. So we know all the poles should be end up in a 0. So this might be this. Does it make sense? No, right? So if you consider, when you consider this line, this won't be in a root locus because there are even number of poles here, and this won't be in the root locus because there is also even number of poles and zeros. So at what direction, by going through which part of the real axis the root locus is going to travel will be given by this breakaway and break-in points. So where it is going to merge and where it is going to diverge, that idea you will get, so that you will get a whole picture of the root locus, you can imagine it properly. So this breakaway points can be given by start from your characteristic equation and just equate it to your k value so that you can differentiate it with respect to s and find the and equate it to 0 so that you will get some poles, some values where this breakaway and breaking points will happen. There might be different poles when you are calculating. Just check whether these poles are in the root locus values. In the first or second, third rule, you would have find what are all the root locus values that is there in the real axis, right? Just check whether this poles lies in this root locus, and whatever poles lies in that root locus will be break-in and breakaway points. So how to differentiate between break-in and breakaway? If this poles, if there is a root locus, for example, so here this will be in root locus and this will be in root locus. Red color will be in root locus. So if I get a pole that is here as a breakaway point, sorry, some point I have found this pole lies here. So how can I call this? Is it a breakaway or break-in point? It is decided based on when this point occurs between two poles, then it is called as breakaway points, because poles tend to push the poles tend to push the root locus towards the imaginary axis. So then if it happens between two zeros, then it is break-in point, because zeros tend to attract the root locus and it pulls away from the imaginary axis. So it has that tendency. Its nature is like that. So if it happens between a break-in or break-up, poles and zeros, it might be a break-in or it might be a breakaway point. We cannot comment on it right now. Based on the system's nature and how many poles and zeros are there, where it is going to travel, and based on the angle of departure and asymptotic angle, we will tend to decide whether it is a breakaway or break-in point. Is there any doubt till this rule 6? Any doubt? I didn't hear it properly. If you have, yeah. Please.
No doubt, ma'am.
No doubt. Okay, right. Thanks. Okay. The rule 7 is, right. So far, you know asymptotes. This asymptotes will tell you what angle the root locus will travel, and centroid, you know from which point the root locus will travel. This angle of departure, it's similar to asymptote. This will also give you angle, but it will tell when it is crossing the imaginary axis. For example, you have some poles, must be zeros here, right? Maybe poles there also be here. So if you have some poles or zeros lies on your imaginary axis, not in origin, lies in your imaginary axis, it will tell at what angle this your root locus is going to cross this poles or zeros at your imaginary axis. Or if it is a pole, it will come to the pole. If it is a I keep confusing it. If it is a zero, it will come to the zero. The root locus will come to the zero. If it is a pole, it will start from that. So this angle of departure will tell at what angle it is going to cross the imaginary axis. Simple. It is crossing the imaginary axis. Don't get confused with the asymptotes. Asymptotes tell you in what angle your root locus is going to travel. this particularly angle of departure will tell you at what angle it is going to cut the imaginary axis. If it is crossing an imaginary axis, some root locus may not cross imaginary axis. At that time, the angle of departure will be null or zero. It won't be even considered. So, for some examples, for some systems, it has to cross the imaginary axis, move from 0 to, when the k starts from 0 and moves to infinity, the system will also be starting from stable region and reaches the imaginary axis. While it is for some value of k, it will be marginally stable, and then it goes to the unstable region. At that point, this angle of departure will be helpful for us. Right. This is rule 7.
Ma'am, one doubt.
Yeah.
Ma'am, what is this Q and on what basis we take it as 0, 1 or 2?
This is like asymptote only, no? It's a number of, whatever number of poles you are calculating. For example, if you have 3 poles and 1 zeros, your Q will be 0, 1. Number of Q will be 2. 0, 1 starts from 0. If you have 4 poles and 2 zeros, maybe 3 zeros, this will be 1. So Q will be 0 alone. This tells the number of Q you have to put here. If you have 4 poles and 1 zeros, this will be 3, then Q will be 0, 1, 2. Likewise, you have to choose Q. And this psi is there, no? Psi only, right? This is psi or phi, whatever it is. This will be calculated based on your poles and zeros angles. Summation of zeros angles minus summation of poles angles. For example, if your test point, if you have a test point here, for example, this is your test point. So you have to calculate, I will make it little simple so that it will be easy to explain this as some unwanted things. Okay. Now I have 2 conjugate pole pairs and 1 poles and 1 zeros here, for example. Okay. So what I'm going to do is I'm going to take a test point here. S0, test point here. So I am going to calculate the angle of this test point with respect to all the poles and zeros lying in the system. So from S0, if I see to this Z1, this is pole P2, this is P3 dash, this is P3, this is P1. Okay, P2, P2 dash, okay, just that's P1, this is P2, P2 dash. So I'm seeing from S0 how much distance I'm in with respect to Z1. So if I want to calculate this, for example, S0 is 1.5 minus 1.5. This is 4 minus 4. So what I will do is minus 1.5. This will be S0 minus. Okay, this will be Z1 minus S0. So I will calculate minus 4 minus of 1.5 plus 0j. This is also plus 0j since it is a real axis. So I will consider this as 5.5. So if I take a magnitude out of it, or if I find the angle for this, this will be tan inverse of b by a. So this will become tan inverse of minus 5.5. This will give me the angle I'm at S0 with respect to Z1. So I'm at this much angle with respect to Z1. Similarly, I will calculate for all the poles, all the zeros, and I will make a summation out of it. That's it. That will give you a psi. That psi will be substituted here so that you will get a whole angle of departure. Just to calculate at what angle I am going to depart from the imaginary axis. We are doing all these things. Any doubt? We can practice sums if you are not so clear about it. Okay, they have given one example. If you see this example, this has 1 0 and 2 poles, right? So your n minus m would be 2 minus 1 equal to 1. So your q will be only 0. For later stage I have calculated here. So your open loop poles, when you find a root, your open loop poles are at imaginary axis. Oh, sorry, conjugate pair of poles, but in stable side, left half of the S plane. And your open loop zeros are at -1, that is also stable. Okay, right. Now, the first rule, what is the first rule? Just locate the poles and zeros of your system. Your zero is in -1, your pole is in -2 plus or minus J3. Okay. Right, -2 plus J3, -2 minus J3. I have located it. So if I take a test point here, then that will be in my root locus because it has odd. If I take a test point here, it won't be in a root locus because it won't be there. Consider this, it will be even. So this is only my root locus value. If I take it here, it won't be there, but here it will become there also. It will be after this, it cannot be, right? So this is not there. Okay, only this green color is in your root locus value. All the points between -infinity to -1 is on your root locus. How it is? When I take a test point here, it will be odd. Okay, right. It's a conjugate pair. We are calculating together only. I'm sorry for this confusion. Right. Let me draw it properly. Okay, this is your 0, -1. This is the poles, 2 plus J3, 2 minus J3. And when I'm considering a root locus, if I take a test point here, this will be odd. So this is in my root locus. If I take a test point here, there will be 3 all together, poles and zeros. So this will also be in the root locus. So from -1 to infinity, everything will be -infinity, everything will be in your root locus. The second rule satisfied. And the third rule, what you can do is, third rule is to check this. Third rule also satisfied. And the fourth rule is finding the asymptotes, at what angle your root locus is going to travel. So for finding the asymptote, this is the formula. So already we calculated q equal to 0. So just put q equal to 0, it will be 180 degree. So your angle of asymptotes will be 180 degree. At 180 degree, this root locus is going to travel to 0. One root locus will go to this 0, another root locus will go to infinity. So this is your angle to travel to infinity. Right. The next point is, this is rule 4, and rule 5 is calculating the centroid. There is no, there is only one angle, we are taking that. And for calculating the breakaway point, just rearrange this equation so that you will get it in terms of k. So this will go down and this will come up. So it will be rewritten in terms of k, and differentiating with respect to s, you will have, and equating it to 0, you will get a quadratic equation, polynomial equation. And finding roots of this equation, you will have 3 roots must be there, right? Two a square. Yeah, this is not being differentiated. This will be 3s square plus 12s plus 9 equal to 0. So you will get minus 12 plus or minus root of 12 square minus 4 into 9 into 3. 1281 divided by 6, right? So you will have two roots. One is minus 4.16, another one is 2.16. Just see which point is in the root locus. Is 2.16 is not in the root locus, so the minus 4.16 is your breakaway point. Here minus 4.16. Why it is breakaway? It is not in between anything. So based on the next step, we will consider whether it is breakaway or break-in. Okay, they have given it as breakaway. Let's see first, and then this 5 rules completed, and then we are calculating the angle of departure. Since there are conjugate poles involved, we are going to angle of departure will be helpful in this case. So we are going to calculate. The overall angle of departure would be plus or minus 180 degree plus psi, where psi is the summation of individual angles of zeros minus summation of individual angles of poles. Okay, first let me take a test point. This minus 2 plus j3 I am considering. So from this we are going to calculate the angle for this. I will calculate it here. So I'm going to consider P1, that is minus 2 plus or minus J3 plus J3 here, not plus or minus. Just I'm considering the positive pole pair, minus 2 plus J3. I'm going to take the first point as first 0 as Z1. This is P1, this is P2. Okay. From P1, I'm going to calculate it for Z1 first. So if I want to calculate this, it will be minus 2 plus j3 to minus 1. So if I calculate this, you will get minus 1 minus of minus 2 plus j3. So this will give you minus 1 plus minus 1 minus j3. Is it right? Just 1 minus j3. So this is the overall answer I am getting. If I do a tan inverse for this, 3 by minus 3 by 1. Tan inverse of 3 would give me, minus 3 would give me, I'm calculating it. Three tan of 3 1 divided by tan of 3 to 0.05. Should be minus around minus 71 I'm getting. Right? Similarly, from point P1, I am going to calculate it to P2, the other conjugate pole. That you know it is straight minus 90 degree or 90 degree, whatever way you are considering. I am considering the inner pole. So it is inner degree, so it is minus 90 degree. Just whatever way you are following, just stick on to that. Now that's it. Only 1 0 and 1 excess pole is there. So this psi would be 180 plus minus 71 minus of minus 90. So it will be plus 90, 180 plus 90 minus 71. This will give you some value related to 270, 200 or 90. Okay, 270, this will be 198 degrees, right? Around 199 something, around you will get. So usually we will consider in counterclockwise direction. So if you minus it from 360 degree, you will get some value around 160 degree, 161 degrees. So that is your angle of departure. At a degree of 161, it is going to depart from your imaginary axis or conjugate poles. Right? For this it is 188, or for this it is 161. Just same 161 from opposite direction, it is again plus 360. That is the difference. Any doubt in this? At first it will be little difficult to calculate all these things. If there are too many poles and zeros, it will again, there is a scope to make mistakes here. So by practice, we can master this. Any doubt? Can we proceed to the next steps? I'll give you a minute. Try solving the practice assignment questions. If you have any doubt, please discuss on the group, or we can discuss in the live sessions also. Okay, I'm proceeding to the rest of the rules. The rule 8 suggests the intersection of root locus with imaginary axis can be determined using route criterion. So we have similarly how we calculated asymptotes angle and centroids. Here we are calculating, first we calculated at what angle it is going to go through the imaginary axis, that is the angle of departure. Now at what point it is going to go through the imaginary axis. If the imaginary conjugate pair of poles lies on the imaginary axis, it will go through that. You don't need to calculate this. If the conjugate pairs of poles don't lie in the imaginary axis like in the previous example, then at the same angle it crosses that pole, it will crosses the imaginary axis but at different points. That's it. Because for example, if the root locus is crossing like this, your pole pair is here, but at the same angle, it won't cross the same value here, right? It will cross a different value here. So that value point can be calculated using this route stability criterion. The same thing what we practice so far, just you are going to use the multiplication of the poles divided by multiplication of the zeros. K should be in this form, because when you rewrite your transfer function to find the k, you will have poles in the numerator, zeros in the denominator, right? The normal thing what you did for the last step, that the same step you can do here also. Right, when you equate it to 0, similarly you will get the roots, and that roots is the one it is going to cross at the imaginary axis. Right. So you know that marginal stability, right? When you want to find whether it, when you see whether, sorry, when there is any poles that is in the imaginary axis, we would call it as marginally stable. So similarly in route stability criterion, if this first column, any of the elements goes to 0, then we will call it instead of that positive or negative sign change, it will go to 0 after, even after substituting epsilon, then we will call it as marginal stable system. Or if there is any single pair of poles that occurs from the auxiliary equation, then also it is called as marginally stable system. So we will look for the value of k so that the system will go to that point. So that point will tell you where it is. For that gain, you are going to cross the imaginary axis at that point. So for this, so if you see here, if k equal to 256, it will become 0. So that is the criteria for this. Then the auxiliary equation becomes 8s square, the previous one. If it goes to 0, we will consider all the rows will go to 0 according to this problem. So we will consider auxiliary equation 8s square plus k equal to 0. And then you will, since k value we know, we are substituting it there and finding the roots. So at this root, it will cross the imaginary axis. So when you use the auxiliary equation, since the intermediate terms are missing, you will always have the purely imaginary values, purely imaginary roots. So if it is a repeatable, it is unstable. If it is a single pair of roots, it is marginally stable. So you will cross that imaginary axis at this point, this root 32 for this system. Is there in 6? Okay, this we can discuss after this. I hope this 9 rules are clear to you. You will be able to solve a problem, I think. We can solve one problem and see how well we are able to solve. What example I took last day? S into S plus 2 plus S plus 4, right? We will see some other example today. We will solve this problem. Today is 23. So I'll try to quickly solve this. You please try to answer this simultaneously so that we can see how well you are understanding it. Okay, so how many poles and how many zeros are there? Just type in the chat box.
Then three,
Yeah.
1 0 and 3 poles.
Right, good. Thanks. So it will be n equal to 3, m equal to 1. Then it will be n minus m equal to 3 minus 1, 2. So your q value will be 0, 1 you are going to take. The first point you can do is, what you have to do is plot the root locus. Plot the poles and zeros of your systems. Whenever you are plotting pole zeros, don't forget to do this sigma and j omega to mention this, okay? Right. If you find the poles of it, I'm not going to spend time on it. So I'm just writing it straight away. Minus 2 plus or minus j 2.64. This is the poles if you find poles of this equation. So one pole rails in 0, another is a complex conjugate poles. Right. So another 0 is lying on minus 9. Right. So now I'm going to represent it using this. One pole is at the 0, another poles are at minus 2, 2.64, right? So somewhere around here I'm considering, and 1 0 is at the minus 9. I'm going to represent it using here. Minus 9, 2.264, minus 2 plus, minus 2.264j. This is 0. Okay. Now see, tell me which one lies in the root locus. If I take a test point here, will it be lying in the root locus? the number of poles towards
Yes.
right will be odd, so it lies in the root locus. Right. If I
Yes,
take a point here, will it lie in the root locus?
No.
No, it will be, because you have to consider this conjugate pair as a two different poles. So 1, 2, and 3. So this will also be lies in the root locus. Okay, be aware at this point. This is not a single pole pair. You have to consider this as two different poles. P1, P1 dash. This is P2. So this will also lie in the root locus. When I take a test point here, will it lie?
no, ma'am.
No, it won't, because it will be considered as even, so it won't. So the value between -9 to 0 will be lying in the root locus. This is the value of root locus you will get. Right. So what is the next point? Finding the asymptotes. At what angle it is going to drop. So till now we have completed 3 rules. We are going towards the rule 4, that is finding asymptotes. The asymptotes angle value will be, I might be using this wrong, please check with the official document. Psi phi something, sometimes I will mess up with that. 2q plus 1 divided by n minus m. So q, you know, you have to find it for 0 comma 1, because we have 3 poles but only 1 zeros. So one pole will go from, one root locus will go from the poles to 0, and 2 will go from poles to infinity, right? Now finding it for it, so if you put q equal to 0, it will be 180 degree by 3 minus 1, 2, 2 only, right? So this will give you plus or minus 90 degree. I think there is a mistake here in this book. They have calculated it as 3 n minus 1, n equal to 3, m equal to 0. That is wrong, right? Yeah, that must be wrong. Okay, that's all. Then q, when I put q equal to 1, it will give me 3 by 2, 180, 90 into 3, plus or minus 270 degree. Okay. So this will be q naught, sorry, this will be q naught, this will be q1. So my asymptotes will cross by 90 degree into 270 degree. So the fourth rule is centroid you have to find. Centroid is sum of the poles, sum of values of poles minus sum of values of zeros, divided by number of poles minus number of zeros. So sum of poles will give you 0 minus 2.2 plus 2.64 j minus 2 minus j 2.64 minus of minus 9 divided by 3 minus 1 by 2. So this will give you this, imaginary terms will get cancelled, minus 4 by 2 minus 2. Oh, okay, this 9 I didn't consider. Okay, minus 4 plus 9, 5 by 2, 2.5. So your centroid will be at this is 1 pole, this is 1 0. Your centroid will be at 2.5 minus 9, 2.26. So if you have
Ma'am, won't it be negative 2.5?
no centroid can be anywhere.
Okay.
Breakaway and break-in point should be in the root locus. The next thing is rule 5 or 6. I don't keep the count. So this is breakaway and break-in or break-in calculation. So for that, okay, how do we calculate breakaway break-in? Equate it to k and differentiate to 0 and find the poles, right? dk by ds equal to 0. Okay. What is the k? I think there is no breakaway break-in, but just calculating for your understanding. So this will give me s into s square plus 4s plus 1, 11 divided by s plus 9, which is equal to 0. If you make any mistakes, please let me know. Just 2 minus 2.6 by s plus 9 equal to 0. This s plus 9 will go to 0. Only this will be there. Is it right? Equal to 0. S into s square plus 4s plus 4 minus or plus this will be 2.264 square. I don't know that value. So it will become s cube plus 4s cube s square plus 4 plus 2.264 square into s equal to 0. So this will give you a point. Since I don't have time, I'm going to.
Ma'am,
Yeah.
it will be 4s plus 2.264 whole square s, right?
Will be 4s plus where? Which point? Which after this?
No, no, ma'am, you are right. You are right.
So I'm going to use some online calculator. If you can solve it in calculator and tell me, it will be helpful. It's q plus 4 square plus 4.4 plus 2.264 square into x. Okay. Okay, it gives the points that are not in the root locus. It gives out of this range. So there is no breakaway or break-in point. For this problem. What is the next step? Angle of departure. So angle of departure would be equal to two q, right? Plus psi, where your psi will be calculated from individual thing. So whenever I'm considering P1, let us say S is equal to 0, theta 1, I'm writing it here, just go through this since we are running out of time, and we can discuss this later if you have any doubt here. 180 minus tan inverse of 2.64 by 2. It will be like this. So if I see from here, I'm going to calculate the angle for this. So I will do my 0 minus 2 minus 2.264j. So this will give me minus 2.264 by 2 tan inverse of. So you will get an angle for this. Similarly, you will do for this pole and this 0 also. This 0 will be 180 degree or 0 degree, whatever convention you want to keep. So just follow that convention throughout. Okay, and while calculating, when you calculate all those things, the angle of departure you will get is minus 16.4 degree. If you don't get the same degree, just comment in the discussion forum, we can discuss on this. I will give you the detailed output of this. Okay, right. So similarly, we will calculate angle of departure from P1 and P2 for all the other poles and the zeros. So two angle of departures you will get. So from P1, how much angle it is going to depart, from P2, how much angle it is going to depart. This is from P1. Minus 16.4 is from P1. P1 is S is equal to 0. P2 will be 2 minus 2 plus 2.26, the positive conjugate. This is around 16, no. Angle of departure from complex pole P3. Okay, this is from 16.4 degree again. So you will get two of this only for conjugate poles. We are calculating P1 and P2. Minus 2 plus 2.6. This is minus 2 minus 2.6. Just try to calculate this. And rule 8 is that at what point it is going to cross. We have already calculated this value, right? K equal to here. Just take this equation and equate it to 0. Do a route stability. Find the characteristic equation and do the route array stability and look for what values of K it is going to 0. So that is the K value. When you put it in the auxiliary equation, put that in the auxiliary equation, you will have an imaginary root. So that is the imaginary point where this root locus is going to cross it. That's it. This is the entire root locus plot for this particular system. It would look something like this. This is a pole, this is another pole, this is a 0. It's going to be like this. Right? This is the point you will calculate from this step. Here it is around 4.4 something. If you have any doubt, we can discuss further on the forum or in the next class also. Right? So you have to be thorough with these rules. So it might be asked like if the system will be given and you are asked to plot the root locus, find the root locus from the given options in the quiz 2. It's even if it is subjective, some higher mark questions are there. You have to solve it by hand and then you have to pick it from the values. breakaway or breaking points can be asked, centroids can be asked, or sometimes we will give a point and ask you to find whether those point is in the root locus or not. So it will, if you follow all the steps, you will be able to answer any of these questions. That's it. Just see from the rule 1 to rule 7 how you have to calculate a root locus. You will be able to visualize the root locus, draw the root locus by hand by following the steps. That is the only thing you have to master yourself. Any other doubt? If no, we can wrap up the session.
The syllabus for quiz 2 is week 5 to week 8.
Yeah, week 5 to 8.
And ma'am, the quiz will be subjective or objective?
Objective it will be.
Okay, ma'am.
You can expect short answers like true or false, or numeric type short answers, or one word short answers, and but short answers won't be like easy questions. You might have 2 marks, 4 marks for that. For 4 marks, you have to solve it by hand and you have to choose those options. Likewise, you can expect MCQs or MSQs, kind of mixed up. But there won't be any paragraph questions. You don't have to type or explain anything.
Okay, ma'am.
Yeah, you can leave if you want. If you have any doubt, ask me. Okay, you can leave if you don't have any doubts.
Thank you, ma'am.
Thank you.
Thank you.